record. All right, everyone, it's Monday again. We are having another class with Dr. Greg Wright. And what's the topic we're going to learn today?
Okay, we're going to just do a little bit of a sideways slide and go over a few areas of Bitcoin that people still don't seem to understand again, rather than continuing with the other thing, which I'll do next week and give you some more papers to read. I'm going to cover the notion of sort of Bitcoin, encryption, cryptocurrencies, etc. Now, I'm trying to make this very clear because in the past I've used the terms in a loose manner. I mean, because they are the same algorithms that you find in encryption, you could actually say that it's crypto, but that leads to other problems. So I'm shying away from that now, even though I've been loose with it in the past. An example why I'll say this is in IPsec, which is the sort of encryption methodology and VPN methodology that many people use, there are also non-encrypted versions of VPN. For instance, an tunnel, authentication header. Now, you could sit there going, why would I want to have a VPN that is not encrypted? An example being SSL TLS even supports this. It has mode. Now, with mode, you can have information sent back and forwards between yourself and your web browser, but it can be viewed, it can be seen, it is public.
Okay.
So tell me why, give me an idea what you think that might be useful for.
Yeah, just sometimes you don't have to, encrypt your communication for some reason. Maybe
not all. You don't always need to, but it's also great for the system administrators, for instance. So right now, when we're talking about sending data between your web server and the client, effectively everything in between those two points is dark. So you can't see if someone is trying to send other information, attacking the web server, etc. Now, some of the concerns are around privacy and other such information, but I'll start describing how obfuscation allows you to retain all of that as a private set of data while still accessing different sites. Now, the way that most people look at this is sending information back and forwards as a large thing in streams. That doesn't always need to happen. So have you worked on things like Ajax or any of those horrible things like that? Yeah.
Okay.
So now when you're doing it, what you'll realize is you're not sending everything back and forwards all the time.
No.
So you want to tell the audience what you should be doing. I'll say should because many people do this wrong and actually update the client information as you're going. So tell me what you should be doing.
I think ideally you just send the data that only change in the front end. You don't have to send the whole page every single time. For example, you watch like BBC.com. You maybe only check some click some buttons, but everything else on the home page it should not change.
So quite often as well, when you're looking at someone going to BBC, you already know that if they're putting in a default page, this is the information they're going to get. As an attacker monitoring your site, if they can see that you're making connections and doing certain calls to BBC, they know the base data you're going to get. Do you want to try and hide that from them, even though they know?
No.
But what you need to do is make sure that the integrity of the data is protected. So how would you think you'd do that?
I think one way just to have a signature.
That's one way, yes. So do you know what authentication header is? mode.
No.
So apart from the more normal VPN methodologies, they're like ESP, etc., which doesn't mean anything to I can read your mind or any crap like this. AH is a fundamental sort of methodology used in things like VPN tunneling to validate the stream of data. It will do digital signatures, it will do hashing, etc. It verifies integrity.
Okay.
So in the CIA triad, there is confidentiality, integrity, availability. Availability can't be protected by encryption. Sorry, but no one can stop your site being DDoSed because you have encryption turned on.
No.
So equally, you cannot guarantee that data has not been altered because it's encrypted.
No.
Can you think of some ways that might be what I'm saying is valid? So I'm not just making shit up.
I mean, because I just my guess is because the ciphertext usually looks like a it's like a random strings. So if you change it.
So if things are badly organized and set up, one of the problems that can occur is a replay attack. Or there are still man-in-the-middle attacks, etc. So an example of a man-in-the-middle attack would be, I'm really sending to someone over there, but you get my data stream, and I encrypt it to you, you decrypt it, and then send it on, because you've managed to fool me into getting your keys. In which case, this was a part of the problem in the sort of initial version of IP to IP and Bitcoin. But to my defense, it was alpha.
Yes. I think you've been saying this for a long time, and people just say that you can be man in the middle attacked. So you just get rid of it for whatever reason.
So I know it's alpha code. So everyone shits on me and says, oh, it's broken and whatever. The simple answer is, what you could have done is implement other methodologies, but I wasn't thinking. I'm an ASPI, so I'm basically a Vulcan. I understand truth tables, logic. What people tell me, I don't always get lying. I'm actually quite good at poker because no one believes that I won't bluff.
Okay.
So everyone keeps expecting that I'm bluffing, and whenever I make a mistake, people think that's a bluff. It's not, but I didn't say that live. No.
Okay. Just don't play too much poker. Yeah, that's what I'm saying. Maybe they put you at a disadvantage.
I actually don't do as bad as, I mean, I actually generally do quite well because I can work out all the probabilities, etc. I mean, the issue isn't that, it is people expect me to bluff, and when I don't, I actually gain an advantage because I don't react the way they expect.
Okay.
Although now that I've said that, I've probably just screwed up every poker game I will ever have again. If anyone's smart and listening. No, but going back to what we're talking about. So we can sort of protect information without having to necessarily know what we have to protect. There are multiple ways of doing this. Now, in the traditional manner, it would be PKI. Now, do you want to tell me what you think that would mean and how that would work?
So basically, it's like a public information. You have somebody's identity and it's corresponding public key. So there's no way people can do the attack by placing some middleman, because if you're communicating with Alice, you know her public key. You are not using, I don't know, malicious public key. So it's always good.
Yeah, I know. That's the little problem though. Everyone says, but you can't, but you can. So if we look at the DigiNotar attack, what happened there was one of the trusted certification authorities over in old Dutchland there, Holland, they were compromised. And they were a minor, small player, but because of the web of trust structure at the top of PKI, what happened was many other institutions ended up trusting their keys. So if you can compromise the CA, which is a hard attack, then you can basically compromise everything. But there are other ways of doing this. Another would be if I can compromise your browser or app. So if you can compromise the browser or app, then I can make you believe that either this is a valid certificate and display it, or that I'm going to a valid site and display it. So as an example, if I was to load there is actually a key structure in SSL for 0 encryption, 0 signature.
Oh, really? Okay.
So it will have a 0-bit key length. So basically, it's encrypted with a 0-bit key. Yay. It's a testing sort of thing, but you can force this to occur. So what do you think might happen if I have a 0-bit key being used for my encryption?
It just there's no encryption, plain text?
Exactly. It's plain text. Now, if I compromise your browser and I redirect, even if it's already compiled, I do an injection string and I redirect, so I go round a loop that checks now whether you've got a valid key and then displays green, and I just go, no matter what the key is, display green. What happens?
It's compromised. You thought it was you're talking to Alice, but actually you're not.
Yeah. So all of this can be done on Bitcoin wallets, etc. But there are methodologies in Bitcoin. Bitcoin doesn't need to fall for these same problems. I have mentioned many times, my problem is I keep assuming people, it's a mind problem with Aspies. I keep forgetting that not everyone knows everything I know.
Okay, that's
right.
I don't know anybody else knows that much as you know. So
well, no one knows the same things as everyone else. So this is something that I'm approaching 51, but I'm slowly getting to the point where I'm understanding that, people don't really understand things the way I understand them.
Yeah, that's a saying. So, I heard common sense is not common. So.
Yes, I know. So now the thing to think about is we have to start moving away from the existing model, which was used in even SSH, but especially in TLS SSL, and move away from the PKI model into something that works. So when I'm setting up information, rather than having a existing CA PKI system, what I need to start thinking about is, how do I stop something being compromised if it is on the blockchain? I publish it widely, right? So if I'm a government organization and I publish my certification key as the IRS, as the ICE guys, like customs, then once I've done that, then I can tell from that point forward. Correct?
Yes.
Now, can someone then exploit something prior to a date?
Prior to, yes.
So,
because
how would they do that?
Because it's not a public widely distributed yet, so it's not on
but
blockchain. That's what I'm saying.
but that's what I'm saying. If I've sent it to the blockchain,
Uh,
now I have a point in time where I can say, this is me.
Then it's very hard to.
Exactly. So then I might be able to lose a key, but it's only at a point in time. For instance, with the DigiNotar attack, there had been a few banks who had used PKI for trialing like home loans and things like this. Now, what happens when someone compromises a certificate and a key, and it's not on the blockchain, is that there is no point in time. Can you tell me how you would tell the difference between a contract signed today, saying the year 1999, and one signed in the year 1999?
You cannot.
Well, you can, but it's really difficult. What you now have to do is you have to go to people and physically go, okay, you're the witness on this. You're a lawyer. Where are your notes? Can you give me evidence? And it's messy and expensive. So in theory, like you were saying, no, you can't, but you can, because there are always records people keep. So I use a public notary for a lot of things, and she lives not too far from here, and she has a piece of paper, like a little notebook, and she keeps it, and it's in order, and it's not one of those ones you can tear pages out of or add things back into. It's one of those ones where if you tear a page out, you know the page is gone.
Okay.
Now, each notebook is then sequential. If anything is missing, it's known.
Okay.
And she's got like 30 years worth of this crap.
Wow, that's okay.
So
not an easy job.
If you think about it, if you need to verify something in that way, you can, but it's hard. Now, what we want to do is make this simple. So we want to have the publishing of sort of root keys. So we've been talking about 42 hierarchies and other such things. And there's many other ways that we'll get into eventually of doing this. But if we have a key, because of the homomorphic properties of ECDSA, we can create subkeys. And those subkeys can be used on the blockchain, while the other key is not.
Yes.
We can even secretly or pseudonymously or something like this have a hash of a key, and that hash of a key can be utilized in forming information that we don't need to disclose. So if I publish the hash of a key on the blockchain and I've never used that key on the blockchain, can you tell me how does someone get my public key now?
They cannot. It's hashed.
Well, they could go and sort of raid the house and get whatever I have, that sort of thing. But it's much more difficult. I mean, when we're going into an Ocean's 11 type movie scene to steal my public keys, then that's not the same as someone just nicks it off my computer. So as we're thinking about this, what we now have is a methodology to tell when things might have been compromised, where they've been updated, where anything's changed. So not only that, but if you haven't compromised other keys, like you've just compromised the certification authority and have fake ones, then you may not have any changes to the keys and everything can be still validated.
So in this scenario, if some CA's, let's say rootkey gets compromised, does he publish like a update on the blockchain so everybody else knows? Is that how it's supposed to work? There's some way to
so we can do
revoke
revocation.
It,
Of course. We can actually put something on the blockchain from a different key. It could be a known revocation key that if it ever signs a message on the blockchain, basically goes from a I have this transaction to I don't. It doesn't even need to be that. It could be a UTXO. If that UTXO ever changes from a I'm a UTXO to I'm a spent transaction, it is now invalid.
Okay.
Further, you could even have an update process. That UTXO was spent to this new address, and that new address is considered valid.
Okay.
That could be done with a timed sort of update, so that 30 days from when that happens, the new key is accepted, meaning that apart from certain types of revocation, you can now update your key where people know that it's a valid update, have time to check. People can alert if there's ever any attacks or anything like this.
Okay.
So going back to the original with AH, etc. Now, if we have authentication header, and I'm not going to go into the details of how it works, it's, people can look it up, AH, authentication header, IPv6, IPsec, then that will allow us to have authenticated tunnels that the integrity of every packet is matched. Now, if you have the hashed integrity, not just a CRC and checksum or something silly, but the correct hash that is digitally signed, tell me what you can do to something in the stream.
Nothing. You cannot change it without invalidating.
Well, you can do something. You can break it, and then people will know, but you cause extra bandwidth and that sort of problem. But you're not attacking the other side. You can do a DOS attack where you break things by injecting extra bits of packet. But all I have to say is DOS attacks are very wanky. They're from low-grade hackers who probably live in their mum's basement. But if you start going a bit further on this, that means we can build this into not only like clients and applications. Start to think, what happens if I want to build this into my application, say my wallet application? I can start building in real identities, can't I? I can start building in ways of authenticating who I am using either extrinsic information, external stuff, web of trust, etc. And I could actually collate that using external devices, smart cards, YubiKeys, etc., to enhance my security. And now, even though I'm not encrypted, I can send the transaction. So tell me what I might gain from encrypting the transaction like everyone in the BTC core team wants to do. Even Ethereum, they talk about wanting to encrypt information between nodes. Can you tell me what that gains them?
Anonymous transactions?
Does it?
Whatever.
So if I'm a node, can you send me encrypted information that I can't decrypt?
No, that's a waste, right?
Yeah. So the argument is I can send to nodes that I don't know and trust necessarily to bypass police monitoring this stuff, who all they need to do is set up a node.
Okay.
Now, if you're talking about in BTC world, how expensive is setting up a fake node?
It's just very easy. Just buy a Raspberry Pi. That's
exactly.
Yeah.
Not even a good Raspberry Pi.
Yeah.
I mean, I've got a good Raspberry Pi. I'm doing a what do you call it, power engineering course on at the moment that I get to play with. It's high-end Raspberry Pi.
Okay.
It comes in a box that looks like it's designed to blow something up.
Okay. Yes.
It
You don't
looks
want
like
to take a IED?
yeah, it's like silly. Where is it? If I can get the damn thing unplugged.
Okay.
Whoops.
Okay.
Not plugged in now because it won't. The power plug won't reach. But see,
Okay.
Wow, it comes in a box and everything.
That's like
and it
a
has lots of little
high-end.
buttons I can. Yeah, so that I can. It's got little breadboards so I can plug in the chips that I'm playing with and actually do things. Because, well, but that's way over what you need for a Raspberry Pi attack on BTC Core. BTC Core Raspberry Pi is one of these $5 jobbies, and it can sit there and monitor the network. So what have you gained? Not much. So what I'm trying to get is we've got this system that they're running around going, it can be encrypted, but why? What are we gaining from that? The criminal can send a transaction and not be monitored, but so what? The whole point of the blockchain is it is public. What nobody wants to know is you can always find the transaction, you can always monitor where it's going, and you can always seize it and you can always freeze it. So one of the little things in the lawsuit, or one of the ones, I won't go into which particular ones, one of the silly fools who's a developer has admitted in his response, yes, I could change the code, but no, I can't make the nodes run it. So he has said what I'm saying, that we could reallocate seized Bitcoin, is easy. But nodes and exchanges may not run his code. So let's go into that one for a second, just as a little side junction before we go back to the other. How much do you think nodes spend on the BTC network? Real nodes. Real nodes are called miners. Let's take the top 10. Do you know who the top 10 are on the BTC network?
Top 10? I think Bitmain. Yeah, Slashpool. Yeah, I haven't checked the latest, but
I know, but they're not hard to find, are they?
No, you pretty well know.
So what do you think happens when someone basically goes FU to a court?
Oh, you can easily find them.
You can find them, and there's this thing called contempt of court. And if they don't agree, then it's a sequestration. Do you know what the limit is on a sequestration?
No limit, I guess.
No limit, yeah.
Okay.
So the longer they take to comply, the more money it costs them.
Okay.
Do you know who else can be affected? Exchanges. So you've got this concept, oh, we could just fork. Well, if an exchange runs the fork, that means they're in contempt of court. So everyone says, oh, but you can't get us. So let's take our favorite run by CZ, first of all. He loves to say how he's decentralized and distributed. How do you get to his site?
You can always find him. Is it like a person, right? It's got to be somewhere.
He runs around, but there's a domain.
Yeah.
You know how easy it is to seize a domain?
I mean, pretty easy.
Do you know how easy it is to seize a hosting server?
Yeah, very easy. Yeah.
Do you know what happens when hosting companies don't comply?
The same, like a contempt of
You
court.
seize the hosting company.
Mm-hmm.
So I learned all this the fun way when I worked. Like I used to do work for Australian police, um, contract stuff with like operations for RIA and other aspects of the privacy industry.
Mm-hmm.
So some of these people hate me because they know who I am.
Okay. Yeah.
Because I've been on raids involving, uh, well, basically shutting down servers, seizing domains, etc.
Mm-hmm.
Lots of
Yeah.
fun.
Yeah. Not the cyberpunk. They are looking forward to find.
No,
Yeah.
so I'm to them the equivalent of the Antichrist.
But
But
yeah.
I feel the same way against them, so don't worry. Now, going back to what this means. So the problem here all comes down to if I want to hide my information, why do I care? There are some things you want to maintain for privacy, some things you want to encrypt. But if I'm building a secure site, I may or may not need to do all of that. If I'm displaying differently to you because of a key that updates based on every occasion, and if you think about it, if you've got a secret and then there's a new key value, and we use a HMAC algorithm, and we update, say, session ID, HMAC with secret. Tell me who can get in there and redo that.
Not just you and me. If just we are
Exactly.
communicating. Mm-hmm.
And so effectively, we have this information that no one else can use, that is a single use item that is transmitted over, or basically integrity assured transmissions. So if I'm running an Ajax type page, or whatever the hell is new because I'm old and I haven't really been involved in any of this stuff for ages, and you, on the other hand, are coding it and wanting to make all that, and all the client side script is there. Can you tell me what an attacker can get? If they want to simulate what I'm doing, but it's HMAC'd.
They like a man in the middle because they cannot modify it.
Well, they can't modify it, but what else do they know? So they need to be able to validate something using the HMAC, which, depending on different input from me and you, will be different.
Mm-hmm. They cannot modify it, right? So
they can't modify it, but they can't even use it. Remember, a hash and a HMAC are different because there's a secret on the HMAC.
Mm-hmm.
Remember, I don't need to actually even worry about man in the middle, because if I have your root key and we've got this 42 Diffie-Hellman process, I don't care. I'm not communicating with you at all. It's magic. You already know the number. I already know the number. The attacker doesn't. It doesn't ever go out across the internet. There's nowhere to take it.
Yes. That's the shell secret which just you and me can derive, right? Yeah.
Exactly. So if we've got that information and we can ensure that the integrity of data between two known machines is okay, we might want to encrypt some things that we're sending, which we can do over shared secrets, etc. But we don't need to encrypt everything. And that actually allows us to create systems that are more open while being secure. Right now, the default is encrypt everything, which is Horrible. The cypherpunks will say, oh, but the government can monitor us. Oh, fuck off. That's my answer to that one. The real problem is not the government. The real problem is all these wankers trying to steal your information, the cyber criminals, etc. The real problem is the malware people, the ransomware people. The government are the least of your problems. They can already get information as soon as they subpoena things anyway. And if they've subpoenaed your stuff, they'll subpoena it properly. So government ain't the issue. The issue is the people who don't work by court order. So what we need to make sure is that we can protect from them. And having our administrators being able to see this is not an attack, even though I don't know what the hell it is good.
So in this sense, how is just encrypting everything not good? Just a performance issue, or?
One, it's a performance issue, and two, it means that no one can see what's happening.
Okay.
How do you tell if someone's doing an exfiltration of your company data if everything's encrypted?
You can. I don't know. Is virtually impossible? Yeah.
It's not virtually. It is impossible.
It is. Okay.
So right now, what we have created are methodologies to allow big holes throughout our entire network.
Mm-hmm.
No way of protecting them. We can't see what's coming in. We can't see what's going out. Everything goes over HTTP anyway, or HTTPS rather.
Yes.
So now we have this system where we have no idea what we're sending back and forwards.
Mm-hmm.
So can you tell if someone's sending telnet via a proxy right now?
If it's not encrypted, you're saying?
I'm saying if it's not encrypted, of course,
Mm-hmm.
but if you're now talking about someone setting up malware on a machine inside the network and doing what is called shoveling a shell so that people think, oh, I can't break in because the firewall stops me. What happens is the client connects out to the attacker and then the transmissions go backwards. Guess what you don't need to do? You don't need to care which way in continuous sessions traffic goes.
Mm-hmm.
So this was a problem 15 years ago, and it is a huge problem now.
Okay, so how is the scheme you are talking about going to help? Because you are,
okay, so
I'm saying it's like a hybrid, hybrid case.
So
because
I've got a
it's
hybrid.
encrypted,
So
not.
if I know that a particular bit of information goes to a particular web channel, then the chances of that being compromised are lower. Then that is more difficult to actually break into a particular little area on a web page and redefine that.
Mm-hmm.
So if you're hiding and masking information and you're putting that on a site that then filters things to your Ajax application or your whatever JSP page, etc., then that is easy to set up a filter. Even with Netcat, you can set up something so that some of it goes one way and the rest goes to the server, and it can all appear to be working naturally.
Mm-hmm.
Conversely, though, if I'm sending everything to the base page, and then occasionally there are encrypted things, like there's a file being sent, and it's going to a particular directory, so now that file, I can't tell what's in it.
Mm-hmm.
That's a little bit different. That's a bit harder. That makes the attacker's life way more difficult.
Because of it doesn't know which part of the. Yeah, that's part I'm not getting, because compared to one way of encrypting everything, right? Now you are saying some part don't have to be.
Tell me, what do you think would be harder? For the attacker to load a little Trojan on your machine that sits there filtering information at the base level and then goes to the other server pages, the Ajax, the etc., or that the person has to completely compromise while leaving working your client application.
The latter sounds like more complex.
Exactly. More complex you make it, the harder you make it, the harder it is for the attacker. Right now, we're making everything super simple.
So if you're encrypting everything, how's that? That's the part I'm at. Is it like little bit
If you're encrypting everything, then you have no idea what the hell's going over any part of the network. Then malware servers cannot scan things. Why? Because they have no idea what the fuck's happening. If you're breaking things down and treating it individually, you can start looking at actually individually scanning files still. You can actually isolate things still.
Okay, basically you have, if you encrypt everything, like you cannot see anything. It's like a scrambled.
Yeah. So even if we encrypt things, we can actually set things up so that where there are encrypted files, we can still have a salted hash of the internal file that can be sent to a malware scanner, that can be sent to an IDS and IPS, etc. So we can actually start looking at individualized sort of scanning of what's being sent back and forwards, looking at components of it, analyzing all the network information, so that we can actually stop things before they get to machines. We can start looking at analyzing before we break it down, what's occurring. For instance, looking at some of the earlier SQL attacks, looking at more complex injection attacks, etc. So part of what I'm saying here is in creating Bitcoin and the way that we're going forward, we need to move away from this asinine idea of just encrypting everything end to end, and start looking at how we actually form tunnels at the right places to protect part of the traffic, how we enable decryption of information at the right places, and we can do all of that in Bitcoin.
Okay. Two questions. One is if we want to choose what to encrypt, what's not, instead of just one size fits all encrypting everything. What kind of things then should be encrypted? What's not? Is it like anything that has to be secretive? That's the only.
Yes. So what we should be looking at is organizational policy, and going back to the old-fashioned type, actually understanding the data we have in an organization. So what is valuable? What is intellectual property? What should we be protecting and stopping? And here's something to think about. If we do this in isolation and have methodologies of doing file by file sort of updates, then we could even tell when, say, an insider, a staff member, a contractor, starts sending files that are important. We can look at the size, we can look at the formation of them, possibly even have applications for the encryption that tell us what the hash for the organization is, with a salting function so that other people in the world can't tell. Of course, that would also stop things like certain assholes who worked as contractors in American defense organizations.
Okay. I know one who's famous, but
yes, like I said, complete assholes. So those sort of people would then not be able to just stream information out. Right now, trying to find every server on Earth that you can do this from is impossible. Do you know why?
It's encrypted?
Well, it's encrypted. Everything's encrypted. My traffic to my bank, my traffic to GitHub, my traffic to... You can't tell. So you could say, oh, but you can set up all of the main domain and IP servers, and people can start monitoring these. Like if I'm doing a go to PC type application, I can monitor the site, right? But that's done by domain name and IP address. Can you set up a proxy or a NAT forwarder at a home address?
Yeah.
In which case it bounces off my home address and goes back, and no one is the wiser. So this is how people. So if you start doing this correctly and you start doing end-to-end monitoring, that becomes more difficult too. We can actually require that you connect to certain machines for certain types of data. We can authenticate. Right now, we authenticate very simply, but that could be extended. We have the ability to do multiple protocols, multiple keys, multiple everything else within Bitcoin. We could have multiple different, like you could have a session that involves the two users, Alice and Bob, but also have keys for the applications. That would then mean Alice and Bob can only talk on this particular type of file share.
Okay.
So
that's this something like a little bit counter culture, because outside world is always talking about, oh, you have to end-to-end encrypt, like I don't know, Signal.
No, that's
like
said because no one knows anything better, and cypherpunks and assholes have gotten into this area and totally fucked it up. The only way to put it. Complete dickheads who are either moronically dumb or out there with agendas because they're stupid and think everything needs to be one way because they hate the American government, or I don't really care what, have done stupid agendas that make life difficult, saying it's privacy and the state will see everything you're doing. The state won't see everything you're doing. The state will know that you're not doing certain things wrong. They will know that you're not breaking into bank accounts. They will know you're not stealing money. They will know you're not sending child porn. The rest you can have frickin' private, so to speak. So,
just follow up. I think what we covered so far seems to me is independent Bitcoins, no? Because you are talking about there are different keys and using different.
It builds on top of Bitcoin. So what I'm trying to say.
Connection? Yeah, that's the connection. I think I'm.
Okay, so to be secure, to have a hierarchy of PCI that works, PKI, we need to be able to time publish and revoke keys.
Okay, that's how everybody put it on chain. That's the.
Yes. So if people actually bothered to read my damn white paper and then actually took it a little bit further and read some of those references in the back, what they would see is the base foundation of Bitcoin was a way of securing PKI.
Okay.
It's a way of securing certificates. That is the critical foundation of what makes Bitcoin work. I just found a way of actually making it work because of economics. The other guy said, oh, we need a central authority to manage all this because we can't trust, because they're all bloody socialists. My answer is, you can trust economics. You can trust this unseen hand. Why? Because people are fucking greedy.
Okay.
And greed will drive them to dob in the people who are sort of working with them if they're doing something wrong. Guess what happens when you have collaborative groups trying to screw things over? Cartels. One of the cartel members will screw over the rest. Because imagine you've got 5 people in a cartel, and the top one gets 20% profit, and the bottom one gets 5% profit. Guess what happens? Either the top one screws over the bottom one, to get 25% profit, or the bottom one screws over the others because they want more than 5% profit.
Mm-hmm.
Or you have this thing where they divide everything equally, and then this guy goes, I could be making 20% profit, but I'm getting 10. Screw them.
Mm-hmm. Okay.
Welcome to human greed. It is a great thing when you leave it in that sort of way. Self-interest will mean that these stupid idiots will freaking screw each other over and it all falls apart and the system goes back to the default honest.
Mm-hmm. Yeah, that's amazing.
Yay.
Because using greed for good, because usually for whatever reason, people think when you say
exactly.
greed, it's usually bad for
The
whatever
system
reason.
is not about greed, it is about setting the incentives correctly to make sure that it works. So, homework.
Mm-hmm.
We've talked about setting up mask sort of structures before.
Mask structure. Uh-huh.
I want you to think about now being able to set up ways, like you've already done signing,
Mm-hmm.
you've already done Rabin signatures, etc. Think about what we've just talked about and being able to individually, selectively set up something like AH, authentication header. So rather than having a full tunnel, now we can have selective tunneling.
Okay.
All right. And I'm going to end a little bit early tonight,
Mm-hmm.
and I'm going to leave you with that homework.
Okay, it sounds like quite some literature to review, but which should be interesting. Okay.
No problem.
Okay.
Have a great night.
Okay. You too. Talk to you next
Alrighty.
time. Okay. Okay.
See you later.
See
Bye.
you. Bye bye.